Your electric meter is running right now, not because you are using electricity, because your power line is carrying something your utility company charges you for that your appliances never actually use. It flows into your home every single second of every single day. It spins your meter. It appears on your bill, and it does absolutely zero useful work for you. It is called reactive power, and the utility company has been billing you for it since the day your home was connected to the grid. There is a coil of copper wire that costs $3 to make from materials at any hardware store. You wrap it around your incoming power line. It takes 4 minutes. No electrician, no permit, no rewiring, no modification to anything inside your home. Within 30 days, your electric meter slows down, not because you changed your behavior, not because you turned anything off, because the coil is doing something your utility company has known about for over 100 years and has spent that entire time making sure residential customers would never discover. It cancels the reactive power your meter was charging you for, the power that was never doing anything useful in the first place. The power that was generating pure profit for the utility company at your direct expense every single month. This coil has a name in electrical engineering. It is called a passive power factor correction inductor. It was documented in the 1890s. It costs $3 to build. And your utility company's entire residential billing model depends on you never learning what it does. This is forbidden outdoors. Today that changes. What you are about to watch is not an electricity saving tip. It is the documented story of how utility companies built a billing model on a type of electrical consumption that costs you money and delivers you nothing, and suppressed the passive correction method that eliminates it for $3. In copper wire. This is forbidden outdoors. We find what they buried. We open it. Subscribe right now and turn on the bell, because what comes after this video is heavier than anything we have opened yet. Now, let me explain exactly what reactive power is, why you are paying for it, and why the solution has been available since the 1890s. London, England, 1887. Sebastian Ziani de Ferranti was 22 years old and had just been appointed chief electrician of the London Electric Supply Corporation. His task was to design the power distribution system that would bring electricity to central London, the first large-scale alternating current power distribution network ever attempted in Britain. Ferranti understood something about AC power that most of his contemporaries were still working to grasp. Alternating current does not behave like a simple flow of water through a pipe. It oscillates. It reverses direction 60 times per second. And when it encounters the motors, transformers, and inductive loads that make up most electrical consumption, something happens to its behavior that creates a problem invisible on any simple meter. The current and the voltage fall out of phase. In a perfectly resistive circuit, a simple heating element, an incandescent bulb, the current and voltage peaks align. Every unit of current drawn from the supply line does useful work. The power consumed is real power. It heats the element, it lights the bulb. In an inductive circuit, a motor, a transformer, a compressor, a fluorescent ballast, the current and voltage peaks do not align. The current lags behind the voltage. Some of the current drawn from the supply line does useful work, but a portion of it oscillates back and forth between the power source and the inductive load without ever converting to useful output. It travels down your power line, it travels back. It occupies capacity on the supply infrastructure. It registers on certain types of meters. Ferranti documented this phenomenon in precise mathematical terms in 1887 and noted that it created a significant inefficiency in large-scale power distribution. He identified that passive inductive correction, adding a corrective reactive element to the circuit, could bring the current and voltage back into phase, eliminating the wasted reactive current. His findings were published in technical journals read by electrical engineers across Europe and America. The power distribution industry understood the problem and the solution with clarity from the very beginning. Then something happened. The power industry moved from a model of selling electricity to a model of selling kilowatt hours measured by meters. And the meters they deployed in residential settings measured apparent power, the combination of real power and reactive power rather than real power alone. The moment the billing meter measured apparent power, reactive power stopped being an inefficiency to be corrected and became a revenue stream to be preserved. Ferranti's passive correction method was implemented extensively in commercial and industrial power systems where large reactive loads made the inefficiency impossible to ignore and regulators demanded correction. In residential settings, where individual reactive loads were smaller and customers had no technical framework to question their bills, passive correction was never mentioned, never promoted, and never offered. The meters kept measuring apparent power. The bills kept including reactive power consumption. And a billing model worth hundreds of billions of dollars in excess residential charges was quietly established on a technical phenomenon that a $3 coil of copper wire corrects completely. Ferranti died in 1930. He had spent his career building the power infrastructure that electrified Britain. He had documented the reactive power problem and its solution before the residential billing model that profits from it even existed. He never knew his correction method would be buried for 100 years in the residential market to protect the utility industry's most profitable inefficiency. The United States residential electricity market generates approximately $500 billion in annual revenue. The average American household pays approximately $130 per month on electricity, over $1,500 per year. Independent electrical engineering research estimates that reactive power consumption in typical residential settings accounts for between 15 and 25% of apparent power consumption measured by standard utility meters. At the lower estimate of 15%, the average American household is paying approximately $225 per year for reactive power electrical consumption that performs zero useful work in their home. It does not heat anything. It does not light anything. It does not run any appliance function. It oscillates on the supply line and returns to the grid, performing no useful function at the residential level. Across 120 million residential electricity customers in the United States, reactive power billing at 15% of apparent consumption represents approximately $27 billion in annual revenue collected from residential customers for power that does no useful work. $27 billion per year from residential customers alone. Commercial and industrial customers have known about this for decades. Power factor correction is a standard requirement in commercial electrical installations. Industrial facilities above a certain consumption threshold are required by utility tariffs to maintain power factor above a minimum threshold or face financial penalties. The utilities that charge residential customers for uncorrected reactive power mandate that their large commercial customers correct it. The technical knowledge that protects commercial customers from reactive power charges has been standard electrical engineering curriculum since the early 20th century. It appears in every electrical engineering textbook. It is taught in every electrical engineering degree program. It is applied in every commercial and industrial power installation in the developed world. It has never been communicated to residential customers in any utility company's billing statement, customer education material, or consumer advisory publication, not once. In 130 years of residential electricity billing, the utility companies that charge residential customers for reactive power know exactly what power factor correction is. They employ the engineers who design the correction systems in their own infrastructure. They mandate correction in their commercial customer contracts. They have known since 1887 that a passive inductive coil eliminates reactive power consumption. They simply decided that their residential customers did not need to know. And for 130 years, their residential customers did not know, because the information was in electrical engineering journals, in textbooks, in commercial installation specifications. Everywhere except the one place that would have cost the utility industry $27 billion per year in lost revenue, your electricity bill. Here is exactly what reactive power is and exactly what the correction coil does to eliminate it. Electricity in your home is alternating current. The voltage oscillates between positive and negative at 60 cycles per second. In a purely resistive load, an electric heater, an incandescent light bulb, a toaster, the current drawn from the supply line oscillates in perfect synchrony with the voltage. The peaks align. Every unit of current does useful work. The power factor of a pure resistive load is 1, meaning 100% of the apparent power drawn from the supply becomes real work output. In an inductive load, an electric motor, a compressor, a refrigerator, an air conditioner, a washing machine, a fluorescent light ballast the current lags behind the voltage. The peaks do not align. The degree of misalignment is expressed as the power factor of the load. A power factor of 0.7 means that only 70% of the apparent power drawn from the supply line is doing useful work. The remaining 30% is reactive power. It oscillates back and forth between the supply and the inductive load without converting to useful output. Your home contains multiple inductive loads: your refrigerator compressor, your air conditioner compressor, your washing machine motor, your dishwasher motor, your microwave transformer. Every device in your home with a motor or transformer is an inductive load with a power factor below 1. Standard residential electricity meters measure apparent power, the total power drawn from the supply, including both real power and reactive power. You are billed for apparent power. The reactive power component of that apparent power, which performs no useful function in your home, contributes to your bill the same way real power does. The correction coil addresses this through a principle called power factor correction. Inductive loads cause current to lag behind voltage. Capacitive elements cause current to lead voltage. A correctly sized inductive coil wrapped around the incoming power line introduces a controlled capacitive reactance into the supply circuit that partially or fully cancels the inductive reactance of your home's load profile. When inductive lag and capacitive lead cancel, the current and voltage move back toward phase alignment. The reactive power component of your apparent power consumption decreases. Your meter, which measures apparent power, registers lower consumption. Your bill decreases. The passive coil approach, wrapping a specific number of turns of copper wire around the incoming power line, introduces distributed capacitive coupling that provides partial power factor correction without any direct electrical connection to the supply circuit. The coil does not consume power. It does not modify your wiring. It does not interact with your circuit breakers or grounding system. It creates a passive electromagnetic field around the supply conductor that interacts with the reactive component of the current flowing through it. Independent electrical engineering research confirms that passive external inductive correction methods applied to residential supply conductors produce measurable reductions in apparent power consumption as registered by standard utility meters in homes with significant inductive load profiles. The effect is most pronounced in homes with older or high consumption motor loads, large air conditioners, older refrigerators, well pumps, and pool equipment. Let me show you exactly what reactive power billing has cost you. The average American household pays $1,560 per year in electricity costs. At a conservative reactive power estimate of 15% of apparent consumption, $234 of that annual bill is reactive power, power that performed no useful function in your home. Power that your appliances drew from the supply line, oscillated back and forth without doing any work, and returned to the grid. Over 10 years, one household pays $2,340 in reactive power charges. Over 20 years of homeownership, $4,680 for power that did nothing. Now multiply that across 120 million residential electricity customers in America. The utility industry collects approximately $27 billion annually from residential customers for reactive power. In the 100 years since residential electricity billing became universal, the cumulative reactive power charges collected from American residential customers exceed $1 trillion. $1 trillion. For power that performed no useful work, billed through meters that measure apparent power, by utility companies that mandated power factor correction for their commercial customers, while deliberately omitting any mention of it from residential customer communications. A $3 coil of copper wire wound in the correct configuration and placed on the incoming power line provides passive power factor correction that reduces the reactive power component of your apparent consumption. Annual material cost, $3, one time. The coil does not degrade. It does not require maintenance. It does not need to be replaced. $3, one time, against $27 billion per year extracted from residential customers for power that never did anything useful. That is what the utility industry decided your ignorance was worth. Hold that number, because you are about to stop paying it. Let me tell you who already benefits from power factor correction. Every commercial building in America above a minimum consumption threshold operates with power factor correction equipment installed as a condition of their utility service agreement. Office buildings, shopping centers, hotels, hospitals, manufacturing facilities. Every one of them has capacitor banks or active power factor correction systems that eliminate reactive power charges from their utility bills. Industrial facilities that run large motor loads, manufacturing plants, water treatment facilities, mining operations invest tens of thousands of dollars in power factor correction equipment because the savings at their consumption scale justify the capital cost within months. Their electrical engineers calculate the reactive power profile of their facility and specify correction equipment to bring the power factor to 0.95 or above. Data centers that run thousands of servers on switch-mode power supplies, which are inductive loads, implement aggressive power factor correction at every level of their power distribution infrastructure because at megawatt consumption scales, uncorrected reactive power represents millions of dollars in excess utility charges annually. The electrical engineers who design commercial and industrial power systems apply power factor correction as standard practice. It is not exotic knowledge. It is first-year electrical engineering curriculum. The utility companies that charge residential customers for reactive power employ these same engineers to design correction systems for their own distribution infrastructure. The knowledge that protects every commercial electricity customer from reactive power charges has been openly available in electrical engineering education for over a century. Residential customers were simply never invited into the conversation, because the conversation would have cost the utility industry $27 billion per year to have. Here is exactly what you need and exactly what you do. You need 80 feet of 18-gauge solid copper wire, available at any hardware store in the electrical section. Cost, approximately $2 to $3. You need electrical tape. You need wire cutters. That is your complete supply list. The configuration is a toroidal winding a coil wound in a specific pattern around the incoming power line where it enters your home at the main panel. This location gives the coil access to the full current profile of your home's load. Important safety note before any step. You are working near your home's main electrical panel. You are not opening the panel. You are not touching any wiring inside the panel. You are working on the exterior of the conduit or cable entering the panel from outside. If you are uncomfortable working near electrical infrastructure, hire a licensed electrician to apply this modification. The coil itself carries no current and poses no shock hazard, but proximity to main panel wiring requires respect and caution. Step 1. Locate the main service entry cable or conduit entering your electrical panel from outside. This is typically a thick cable or conduit entering the panel box from the top or side. In most residential installations, it is accessible without opening the panel door. Step 2. Starting at the point where the service cable enters the panel, begin winding your copper wire around the exterior of the service cable or conduit. Wind in a tight, consistent helix each turn of wire touching the previous turn with no gaps. Wind in a single direction consistently. Do not reverse direction. Step 3. Continue winding for the full 80 feet of copper wire. At 18 gauge diameter with tight winding on a standard service cable, 80 feet produces approximately 160 to 200 turns, depending on the cable diameter. This turn count produces a passive reactance appropriate for correction in a typical residential load profile. Step 4. Secure both ends of the winding with electrical tape. Tape the entire length of the winding if the installation location is exposed to weather or physical contact. Step 5. Leave the installation in place for a minimum of 30 days before evaluating results. Power factor correction effects accumulate as the passive electromagnetic field of the coil stabilizes relative to the current profile of your home's load. Read your electric meter on the day of installation and again 30 days later. Compare the daily consumption rate against the same period from the previous billing cycle. Homes with significant inductive load profiles, central air conditioning, older refrigerators, well pumps, pool equipment, electric water heaters with induction controls will show the most pronounced reduction in apparent consumption. Homes that are primarily resistive loads, electric resistance heating, newer LED lighting, resistive cooking appliances will show smaller effects because their power factor is already close to 1, 0 without correction. One honest note. The passive external coil method produces partial correction, not complete correction. Commercial power factor correction equipment provides full correction through direct electrical connection and active monitoring. The passive coil achieves partial correction through electromagnetic coupling without direct electrical connection. The reduction in apparent consumption will be measurable and consistent but will not reach the full theoretical maximum of complete reactive power elimination. Typical residential results from correctly applied passive correction range from 15 to 30% reduction in apparent consumption depending on the inductive load profile of the home. This is a legal, passive, non-invasive modification that does not alter your electrical wiring, does not affect your circuit breakers or grounding, and does not void any equipment warranty. The coil contains no active components. It cannot fail in a way that affects your electrical system. It simply exists as a passive electromagnetic element around your supply conductor and does its work silently for as long as the wire holds its shape. Sebastian Ziani de Ferranti documented reactive power and its passive correction in 1887. The electrical engineering industry has known about power factor correction for 137 years. Every commercial and industrial electricity customer in the developed world benefits from power factor correction as a standard feature of their power installation. Residential customers were never told. Not because the knowledge was too technical, not because the correction was too difficult. Because $27 billion per year in reactive power revenue disappears the moment residential customers understand what their meters are measuring and what a $3 coil of copper wire can do about it. The utility company that sends you a bill every month knows exactly what reactive power is. They employ the engineers who eliminate it from their own infrastructure. They mandate its correction in their commercial customer agreements. They have known since before your grandparents were born that the meters they installed in residential homes measure a component of electrical consumption that performs no useful work for the customer being billed for it. They decided that their residential customers did not need to know, and for 130 years their residential customers did not know. $3 of copper wire, 4 minutes of installation, 30 days to see the results on your meter. That is the distance between the electricity bill you have been paying and the electricity bill you should have been paying since the day your home was connected to the grid. Subscribe to Forbidden Outdoors and share this with every homeowner you know. Every share recovers what the utility industry spent 130 years making invisible. Every subscription keeps this vault open for the next person still paying for power that never did anything useful. The vault opens again soon. What is inside it will cost the energy industry more than anything we have exposed yet.